Okay, so good afternoon, everyone. My name is Iqbal Gorewal, Technical Support Manager here at CADpoint. Thank you for joining us again today for part 2 of the webinar, Moving 2D to 3D BIM. I'm joined here by my colleagues Lee Milligan, who took this morning's session, and Architectural Technologies, Jonathan Reinhart, who will be taking the session right now. So in the first session, we had Lee walk us through the theory of BIM and what to consider to start working with it. In this session, Jonathan will show a practical introduction with BIM, with Autodesk Revit and with BIM 360, just to highlight how you can make this transition successful. So just to give you a couple of information about us as a company, some background, CADpoint is based in Crowthorne, Berkshire. We have a team of experts ready to assist you in all aspects of design. We are excited to announce, recently announced that we joined, the company was recently acquired by Greytech UK. So we joined Greytech UK. Greytech is an international BIM fabrication and design software developer for AEC and Autodesk Platinum partner across Europe. We're also partners with some of the most trusted hardware manufacturers in the industry, including HP, NVIDIA, etc. As well as software, our team can also offer introductory training for new customers to advanced courses for experienced users to help you get more from your software. We're excited that being part of Greytech UK, we can also offer you, our customers, a considerable portfolio of technical services and products to enhance design workflows. Benefits of this include industry-specific Greytech software, additional UK training centres, Greytech power packs, technical consulting and custom software development. So without further ado, I will now pass you on to Jonathan.
That's great, Iqbal. Thank you very much for that. So my name is Jonathan Reinhart, and I'm here today on behalf of CADpoint and Greytech. I'm based in Ireland. I'm down in Southwest Ireland at the moment in Tralee, County Kerry, and my background is in the architectural industry. So today I'm going to present a practical introduction to BIM using Autodesk Revit and BIM 360. I have walked this path many times, both in companies that I've worked in as full-time BIM manager, architectural technologist. I've helped a couple of companies move to it, to BIM from CAD and traditional processes. And my current role sees me working with companies on a daily basis, helping them implement BIM. Definitely between myself and Lee, we've got a good amount of experience between us. So I've about 16 years in the architectural industry, master's degree in BIM management, also worked as a BIM manager, architectural technologist, primarily in technical roles, but I've done a lot of designing as well, of student residence of 600 beds, housing estates of 200 homes, and then even one-off homes and home extensions as well, all using BIM and all using Revit. So I've seen a lot of different types of projects. I'm an associate member of the Chartered Institute of Architectural Technologists, currently working towards my chartership, and I present at various UK and Ireland and European BIM events as well, both online and in person, last year or earlier last year. So the agenda, I'm going to do a bit of an introduction, which I've covered a bit with myself, and a bit of introduction to the software. There won't be much, I won't do any replication of obviously what Lee presented today. Mine will be more software focused, and seeing how I've used the software in practice. I'll show you some workflows outside of Revit, just to make you aware of what exists in other BIM workflows, or when working in BIM, there are other workflows other than your primary modeling software. Well, is that Revit or a different type of software? There's lots of other different software to support those types of workflows. Then I'll go into some high-level tips and principles for starting your first Revit project. And then I'll go into BIM 360, which is Autodesk's cloud solution, which is able to store files, access and comment and mark up and allow you to collaborate using the cloud from inside a lot of Autodesk software, one of them being Autodesk Revit and Navisworks. So just to kind of set the scene quite simply, a line I've picked up somewhere from presentations I've attended in the past, 2D or working in 2D is okay. How do we draw this building? How do we represent this in a graphical form? But BIM is okay. How do we actually build this? And I suppose to draw a comparison between those two, when you're working in BIM or in a 3D software, designing and modeling a building, it's actually forcing you to think about those tricky junctions. For example, if there's an existing building, how is your proposed roof going to meet that existing building? Is there going to be any drainage issues? And some of these can almost get forgotten in a 2D process, and I've definitely been guilty of myself. And making the change from using 2D processes that I used for about 10 years and making the transition to BIM, I've definitely seen the benefits of using BIM. So BIM, I suppose, allows you to categorize your space or building spaces into different areas, whether that's kitchen, living, dining, teaching, hospital rooms, hotel bedrooms, thinking of all of these areas as different spaces. And in these spaces, you then have different components or different areas, such as, you might have an island, seating, windows, and this can apply to any project scale. I'm just showing this to in a more simplistic way, particularly for a project I actually worked on. So you can have furniture within these spaces or within these areas, ceilings, walls, lights, light switches, paneling. So essentially what you're doing is you're building up a database of your building components, your building elements, and that's essentially what BIM is. And Revit lends itself quite well to be able to do that, and to categorize this database of information, which in turn is physical or 3D models as well, or 3D objects. So you have, floor finishes, even wall finishes, ceiling finishes, whether that's a paint color, a tile, a timber floor, or different types of timber floors as well. So you get the idea that there's all these different categories and different elements in the building, and Revit just allows you to categorize them in a structured and understandable format. So if you look at a floor, it's going to have a finish, a cost, a specification, square meter size, a manufacturer even, a location, and the same for doors, typical kind of information or properties that they're going to hold as well. And the same goes for MEP equipment, structural columns as well, or structural information as well. So that's what Revit allows you to do, is to organize that information into these type of categories. And what you can actually do is then leverage this information, such as the finishes, putting it into a room data sheet or a finish schedule for your whole project, capturing all the square meters of every room in your building, whether that's a small building or a big building. You're able to categorize this into a schedule, and I'll show you how to do that if I get into Revit for a bit of a demonstration. And the same for doors, you're able to categorize your costs as well, and all of that specification and finishes too. So just an example of some projects I've worked on. I've worked on a 600 student bed residence using BIM, using Revit, in fact, and using Navisworks, Autodesk Navisworks to run clash detection. And this is an example of that model that I've worked on. It is a particularly large model, and I did have it open, but it was just putting my machine under a bit of pressure, and just with the presentation, I didn't want to impede it anyway, so I wasn't able to give you a look at that. But this involved coordination between structural engineers, mechanical engineers, and ourselves being the architects. And we linked in various different consultants models, such as the structural engineering model and the MEP model. But alongside that, not every consultant was actually working in BIM. So we were using a 2D process alongside this as well. And so there were a lot of, I suppose, there were a lot of learning points as part of that 2D process. But it's a typical project. You're never going to have every single consultant working in BIM, and Revit again lends itself quite well to working collaboratively, whether you're pulling in 2D or 3D information. And I have used it on smaller projects as well, just to show you the scale that you can actually go with using Revit, right down to home extensions or one-off homes. it has its benefit for every size of project. It's just how you apply it to that particular project may vary. Obviously, for a complex, larger project, you're going to have a lot more collaboration needs, a lot more coordination needs in terms of pulling out different types of information. And then maybe for a home extension, you're maybe only try to pull out your own particular drawings and your own 3D models as well. So there's slightly different ways of doing that, and different expectations on projects as well. And another project I've worked on, this was 178 houses of a housing estate in Ireland, all modelled in Revit, all modelled in BIM, and I have examples of that in Revit once I get through my presentation as well, just to show you how it was modelled, some of the principles that we use to actually model up the buildings, and just linking in different types of information such as CAD files, such as 3D survey information, and the topography of the site, and even the garden layouts as well. And that was actually some Revit renders that we pulled directly from the 3D model. This is actually a Revit cloud render, which you can do from within the software, just to make you aware of. So I suppose when you're moving to BIM, or moving from 2D to 3D, from an Autodesk perspective, you've kind of got 3 options, maybe 4 options. I know Lee touched on Revit LT earlier as well. So you have Revit, or you have Revit LT as maybe option number 1. And I suppose the full version of Revit does allow you to do model work sharing, which improves collaboration between you and your colleagues, or you and other consultants. And work sharing is quite powerful, and is quite widely used by a lot of the larger companies in the industry as well, in both UK and Ireland, I have seen. You can import point cloud models. So surveyors are more and more working using laser scanning on site to capture existing topography or existing context. The Revit full version allows you to pull that point cloud into your actual Revit model. Therefore, you're able to model around it and get accurate site information while you're modeling in a BIM environment. You can create things like conceptual massing, rendering, MEP, and structural modeling as well. Then maybe your second option, and I know Lee mentioned this morning, you've got something called the AEC collection, which is a suite of products. Essentially, it comes with 15 or 20 different Autodesk products, such as Revit, AutoCAD, 3D Studio Max, Navisworks, and a lot more. So just to be aware that is there if you're looking at Revit, and if you're using typically 2 products from the AEC collection, it's actually usually a better value. And if you're using 3 products, it actually works out cheaper. And then you have BIM 360, which I will go into at the end as well. So BIM 360 allows you to store files. It does a lot more than store files, though I don't like to simplify it, but that is essentially what it is at its essence. But it allows you to store Revit files, non-Autodesk 3D files, Word files, Excel files, PDFs, and view all of these in the BIM 360 user interface, and even add different markups, and even tag particular people. And this is all accessible in a web browser, mobile device, and iPads as well. And even things like create RFIs on site, and those type of workflows as well, and technical submittals. And I'll show that towards the end of the presentation. So before I get into Revit and the tips with Revit, I'm just going to show you some workflows outside of Revit. So there's a tool in the AEC collection, or a product in the AEC collection, known as Autodesk Format Pro. And this essentially allows you to model up a building in a basic type of massing form, maybe at the conceptual stage of your building design. And I've seen similar types of software and format being used in architects' offices, where people might start modeling in this initially, or even take a sketch, a hand sketch initially, and then start modeling in format. And I suppose that the biggest benefit of this is that you can import this information directly into Revit, and then convert it into smart objects as well. And I do have a video here. I'm just going to see if it works. It does. So this is a video I prepared earlier. So this is format itself. So outside of Revit, this is a standalone piece of software. It can be used in desktop or on a web browser. So it allows you to actually geolocate your site to an accurate location using Google Maps. So you can accurately locate your building. So I prepared this one. I chose a site in Cork, down in the south of Ireland. And I just chose an initial site that I was familiar with when I was living in the area. So it allows you to import that particular image. But what it actually does is it imports the local weather information as well. So it's taking in the accurate level of your topography of your site, and it's going to give you accurate sun shading and solar radiation calculations as well on your building. So you simply just sketch, 4 lines or the external lines of your wall, and extrude your building to whatever height that you want. So we're going for a kind of commercial office building in this case, and then you can turn on your shadow study and perform a shadow study for different times of the year. And as I said, this is geolocated, and you're able to do that for anywhere in the world, regardless of where you're working. So you can also perform shadow analysis and solar analysis. And I suppose the benefit of the solar analysis, we'll get onto that in a minute. The benefit of the solar analysis is that it can help inform maybe where you need more shading over windows, or maybe where you need less glazing ratio on a particular facade. So we can do it as month peak or year cumulative, just selecting our mass, hitting our checkbox on that. And just by pressing analyze, you'll see a change color now. And what that's actually telling you is the solar radiation on each facade. And as you hover over it, it will actually give you a kilowatt hours solar radiation per square meter on that facade. So it tells you, I need less glazing here, I need more glazing here. My north facing facade is going to be quite cool, obviously. Going to get less sunshine in the northern hemisphere. Or it can also inform where you're going to place your solar panels as well, on which roof facade are they best placed, and what orientation are they best placed as well. You can also automatically apply different levels, and I suppose the benefit of the levels is that the levels actually import into Revit as well. So again, to draw a comparison, you're not just modeling something in 3D that gets forgotten about, which actually is I suppose when you think about it, it's actually lost time when you're producing something. The model no longer gets used, and it's lost time for your business as a designer. So you can actually then export this from Format and bring it directly into Revit and convert it into intelligent information. So one feature that I actually didn't cover in this particular video is that you can actually collaborate in Format through your web browser as well, by sending a link to another designer in your office, and they can design in the web browser while you're designing on the other side as well. It's extremely powerful, and definitely one of my funnest features in Format. So then to just import that into your Revit environment, simply just import the AXM file, which was the proprietary format from Format itself. Turn on your 3D view, and it's actually massing is turned off by default in Revit, just to make you aware. So you can see it's actually imported all those levels that we created. So that's again saving you having to create those levels. Just going to turn on our mass after we imported it here. So just click OK. You can see our mass. So it's basically 4 walls and a roof, nothing else to it. But now we can actually start converting this information inside Revit into an actual building. So we can choose what different wall types we want or maybe have in our template already. So we're just going to place a curtain wall on one of the walls as if it's maybe some sort of commercial office building. I appreciate the design I've shown here is quite square and boring, but you can get quite interesting with Format or even with Revit as well. It was just to demonstrate the principle of importing it in. So we've brought in, we've converted our mass now into 3 sides of curtain walls. We've got one solid cavity wall at the end. Just turn on the colors for those and make it a bit more visual. So that's just in the floor plan. So what we can actually do now is hide the mass that we imported, or you can delete it if you want. It brings it in as just a mass object, as just 2D surfaces or 2D geometry. So now what we can do is actually convert all of those levels into separate floors as well. So there's a mass in there for each level that was created automatically inside Format once we created the level lines. Just giving it, said we want 10 levels at an offset of 3.5 meters. So just selecting all those floors, create floors. So now we've created 10 or so floors very quickly, and this is all in real time. So you can see it's quite fast to do. So now we're just going to pull a section within Revit and zoom in, and you've got a basic yet somewhat intelligent and detailed model created from Format in a matter of minutes. And you can even see the floors have a construction build up in them there as well, and they are connected into the curtain walling. So you can obviously then progress your model a lot further, creating 3D views, creating, I suppose, 2D layouts as well, and even the site location has come in from Format as well, so you don't need to relocate that site as well. You can see it's brought in the location in Cork there as well, even the latitude and longitude also. So that's basically importing that into your Revit environment and converting it into intelligent objects. So that's Format. The next package I'm just going to touch on is Autodesk Navisworks. And the reason I'm making you aware of this, Navisworks allows you to do something called clash detection. So that's taking two different models. So that's taking an architect's Revit model, a structural engineer's Revit model, and bringing them into Navisworks and clashing them together. And by clashing, what we mean is the software will actually tell you if there's a structural beam going through a window or going through a piece of glazing or something that it shouldn't be clashing with. So very easy, and it does have a lot of benefits, particularly with MEP equipment as well, or MEP models. Do they link with structural? Do they link, or do they clash with structural models, or with the MEP or with the architectural model as well? So it's very simple to do. I won't go in detail, but just be aware of clash detection. So here we have on the right hand side, we've got in the red, we've got a structural beam, and on the green element, we've got a HVAC unit or some sort of air conditioning run going through that. And the software has told us that our duct is clashing with our structural beam, and it needs to be rectified. So obviously something needs to happen there. Do we go back to the engineer and say, can you move your beam? But the most likely, I suppose, way to solve this is to go back to the mechanical engineer and say, look, we need to reroute or drop the height, or put a bend into your duct if possible as well. So that's essentially what Navisworks does. It does a whole lot more, such as 4D timelining, quantification, a lot of stuff like that, but primarily used for clash detection. But just to make you aware of it, and again, there are workflows between Revit to Navisworks and even back into Revit. So Revit allows you to change the model once you've discovered a clash, and then Navisworks detects the actual clash between the model for you. So then our primary tool being Autodesk Revit. How this integrates with BIM 360 is you are able to, first off, you're able to save models directly from inside Revit. Go to save as a cloud model, and the cloud model is stored in BIM 360, which is accessible in the web browser by you or anyone that has access to BIM 360. So it could be someone on another project within another part of the country, or even in a different part of the world as well. They're able to access that model or information a couple of minutes later once it's been uploaded as well. So BIM 360 essentially has this type of user interface. You can see it's, in this case, we're logged in through Google Chrome, logged into docs.b360.autodesk.com. That's how you log into it. And you can see we've got a series of files stored in here. So these are all Revit files. I know that by the symbol. You can create your own custom folder structure in here as well. And I suppose to go back to what Lee discussed this morning, particularly in relation to ISO 19650, you can enable your folder structure to comply with ISO 19650 quite easily. And I will show that in some of the demonstration that I'm going to cover towards the end. So this particular project has been set up to store in project files. It's got an architectural folder, mechanical folder, maybe PDF drawing, structural folder. But what you can actually do with these folders is control the different types of permissions for people to access. So maybe you only want the structural engineer to have access to the structural folder, and maybe you only want the architect to have access to the architectural folder, and vice versa. And this can go for any discipline. You might even have the contractor that may only need access to a certain folder structure within there as well. And you can completely customize that. And you can also create markups on CAD files. So you can open up CAD files, you can open up Revit files and 3D views in here. I'll show that in the demonstration. And it auto versions every single file you upload. So if I was to upload this particular file again, a 102 second floor, it would in fact show in here as V2. And I suppose the benefit of that is that it will actually show you a comparison of those two drawings. And I have one prepared. I will show you that towards the end as well. And I suppose, why would you put your information into BIM 360? The main reason is that you can access that on site, whether you're a designer, whether you're performing some type of inspections, or whether you're the contractor. You can bring your iPad or mobile device to site. Excuse me, sorry, my throat. You can bring your mobile device to site, iPad, and pull up all of the latest drawings, all of the latest 3D files, IFC files. It stores over 50 different file formats, not only Autodesk, by the way, lots of different file formats it stores, and you can access that on site. Check all of the latest setting out drawings, check the thickness of a floor slab when you're on site, making sure walls are in the right location, and then you can assign issues and even mark up those drawings on the iPad that will then notify the relevant people, whether it's the architect or the engineer or other designers that need to be notified about that particular issue or item that may have been discovered on site. So now I'm going to dive into Revit in a bit more detail. So primarily what Revit does, it's your modeling tool. It is a 3D modeling tool at a very basic level, but it is a BIM modeling tool because you can attach information to that 3D object or elements within your building. So it does support integrated and multidisciplinary design. So from architects, structural engineers, mechanical engineers, any other type of design or project contributor as well. So it allows you to create your 3D model, but it automatically generates your 2D floor plans as well that you can pull information from, such as schedules, such as visualization for 3D, and even performing different type of coordination using Navisworks, for example, as well. So some tips that I would advise for people when getting started with Revit. Once you're getting started, understand what templates are. When you start from a template, this is essentially what sets what your line thicknesses are, what your object styles are, how your drawings visually appear. In my opinion, the Revit default template that comes installed with Revit, the architectural template, is quite is of really good quality for presenting your drawings. And I definitely know from working in architects' offices and even working on my own projects, making your drawings look, visually impressive is very important, and Revit lends itself very well to that. And I'll show you some tips and tricks. And using something like templates allows you to reuse a template across all of your projects, so your visual styles are going to look consistent on every building or every design that you produce, and will line up with your company brand or your design brand that you want it to align to. So Revit is quite powerful in that respect as well. Okay, tip number 2 is the Revit object library. So what I've seen a lot of companies do, and I know CADpoint support a lot with this, is producing your own in-house Revit library. So a object library, or what are also known as families, for example, can be windows, doors, furniture, cars, people, trees, planting, anything that is a movable object or a freestanding object is found in the Revit family library, and it comes installed with hundreds, if not thousands, of different objects. For your first Revit project, it is a good place to start to actually use the out-of-the-box objects. And then maybe for your second project or next project, then plan what you want to have custom built. So I know CADpoint do support with this. but you can also do it in-house as well. But for your initial first project, instead of losing time modeling up custom objects, I would always work from the object library. I still work with architects and on projects that only use the Revit default library without creating any of their own content whatsoever. And I suppose the reason for creating your own content, if you really want to customize a particular window, the particular fenestration of it, particular design of it, but you can still customize existing families from the library as well. You can change the manufacturer, you can change the finished materials, the opening sections, so they are quite dynamic. So have a look through the object library, see how it works for you on your first pilot project, and then maybe look at building your own custom families as well, or your own library that sits on your central server, or even in BIM 360 for all of your staff to access. So that does come in a pre-categorized library. When you install Revit at first, it gives you the option to install libraries from lots of different regions and countries, such as New Zealand, Australia, US, Singapore, Korea, Japan, everywhere. The UK library, we in Ireland, we use the UK library, and I have seen that being used as well in the UK itself, and even around Europe as well. So it comes in pre-categorized, such as annotations. So that's all of your level heads and notations. Even doors, as we've gone through already. Things like lighting, such as a light fitting that goes onto a ceiling. All of that is in there as well. So lots of different objects in there for you to get started with, and very easily import directly into your Revit model in a matter of seconds. So there is, with these family objects, there is a hierarchy in there as well, just to understand that hierarchy. So the object library, or in a CAD process, what would have been known as your blocks, are in Revit known as families. And families consist of different categories. So furniture, windows, doors are different categories. Within those categories, you then have types. So different types of doors. You're going to have a door with a glass panel in the middle of it. You're going to have a double opening door. They're all types of doors. And then within those types, you're going to have instances. So an instance is wherever you place a door around your model. And I will show you that before I finish inside Revit in the data sets. So when I first start using Revit, probably back in 2012, one of the initial things that I found hard to get my head around was understanding levels. So levels form the basis of everything in Revit itself. So when you model something, it always needs to belong to a level, essentially. Now, you can move things from level to level, no problem whatsoever, but it is, when moving from that CAD to BIM environment, the biggest thing is to understand how the levels work. And it is, once you get your head around it, it makes perfect sense. But it is one I've seen of a sticking point for certain people making that transition, in terms of people are like, oh no, this levels is not making sense to me, therefore BIM is not good. But it's not that way at all. It's just an initial thing. Get your head around it, and it's one of the biggest barriers to getting used to BIM. But easy enough once you get your head around it. Once you start understanding levels, what you'll start doing is working in something called sketch mode. So when you model walls or roofs, or any sort of large elements or primary elements, such as walls, floors, roofs, topography, anything like that, even external ground modeling, anything like that, car parking, landscaping, you'll work on something called sketch mode. So when you engage sketch mode, it shows you something called your sketch lines, and these are the pink lines that you see here, and they only happen in certain modeling engagements, such as walls, floors, and roofs, just to keep it simple for now. So that's the same way that you place walls along these sketch lines. And so walls, when you're placing them, you will choose a wall type, and you can change that wall type at any stage in the project. And wall types are made up of different different wall buildups. So this one, for example, has lots of different layers in it. We've got a finish layer, which is a brick, thermal layer, which will be your insulation as well. We've got an internal cavity blockwork, and inside we've got a plasterboard finish. So that's a wall type essentially. You can make a wall type so that it's just 400 mil thick, and then you can come back later and add the build up into it as well. So I think that's one of the definitely when you're starting off in Revit, is not to get bogged down in this type of detail, because you can change it very easily afterwards. As soon as you change that wall type, it will reflect wherever you have placed that particular wall type as well. So for a lot of my projects and other architects that I've seen starting on projects, they'll just create a basic wall thickness and keep it as one material. It might be just concrete material, 450 mil, and they'll just model with that and then worry about the finish of it later after they've actually designed. So then placing walls, there are 3 different types of walls. You've got a stacked wall, you've got a basic wall, and you've got a curtain wall. So a stacked wall consists of different parts or different types of walls. So here we've got a wall footing at the bottom on our front stacked wall. We've then got a rising or substructure wall. We've then got another element or some sort of brick banding coming up here. And then we've got some sort of cladding or vertical cladding as part of that. So you can create stacked walls that maybe have different wall buildups. Now, my experience, when you're modeling walls in a building, you should always model from floor level to floor level. So from ground level to first floor level, that should be one wall. Then you either copy up your walls or you model again for the first floor, second floor, third floor, but always model floor to floor. That was one of the first rules I learned in Revit, and when I first got used to BIM, and it's definitely one of the rules that has done me great benefit. The reason for that is if you model floor to floor, it actually allows you to make changes a lot easier rather than undoing maybe a 10-story wall. You know that every wall is only floor to floor. So I definitely mark that as a very important point once you start modeling walls. So placing floors is very similar to placing walls. You do it using sketch lines as well. And you just place it in a floor plan view, or in fact in a 3D view as well. And the same as walls, you can just create a single floor thickness if you want, and then you can go back later and add the floor buildup. So we can actually see here what we're looking at here on the right hand side with the table in the image. We've got a floor and we've got some sort of structural floor below that. So the structural engineer will probably have modeled this floor in their own structural model. And then the architect maybe has modeled this particular floor, which is the insulation with some sort of maybe screed finish on top of it as well. So that comes down to coordination as well about who models what, but you can create 2 separate different types of floor just to keep that in mind as well. It's quicker to model a floor as a single thickness and add in all the different layers afterwards, but just keep in mind when you get to construction stage what is the most accurate type of modeling that you need to do, and that's going to vary per construction type, style and project as well. So roofs work the very same way. Using sketch lines, you engage the roof tool. You can place a roof by footprint, so just clicking, it will actually click on the walls, and you can choose the offset, and you can add different pitches to those. So you can say what pitch you want this particular roof to be, or you can draw a roof in a side elevation and it will actually extrude it along it as well. And it works very similar to floors in terms of adding in the build-up detail into that as well. So I'm going to move a bit faster in this just so I can get into the demonstration. So placing roofs very, very easy, and you can create almost any different type of roof. And what I know from working in CAD, it is a lot easier in Revit to model a roof than it might be in CAD, for example, purely because I've had to draw curved roofs and then in elevation, trying to draw that curved roof and trying to work out how it would appear in 2D can be quite tricky and quite time consumption or time demanding as well. Revit does all of that automatically for you. So if you draw a curved roof in 3D, the elevation is automatically produced, so you don't need to worry about any of that stuff as well. And even working out tricky pitches or maybe tricky hips that may occur in the roof and junctions as well. Floors are placing windows and doors. Very straightforward. You can't place a wall in complete or can't place a window or door in complete empty space. It has to be hosted by something. So you'll see some objects are required to be hosted. So for example, a window or a door needs a wall to be hosted. You can't place a door in a floor, for example, because that would not make sense. You can't place a door in a roof, for example, but you can place maybe a roof window inside a roof and maybe not in the wall. And you'll understand that as you start to use the objects. And I'll go back to what I said about using the Revit object library. Start to place windows in walls just to see what will place inside a wall, or even for tables, for example, requires a floor to host that particular object. And that just means that every object belongs to something, and that gives us an association between everything as well. Something I like to use in Revit is the section box. So this allows you to just interrogate your design in a different way, I suppose. Just by cutting through your floor plan. There's a couple of different ways to do it, and I'll show you in the example. And you can even turn on your realistic view as well, just to get maybe a sense of what that room is going to feel like to a certain degree. And then even being able to cut a section through a 3D view is extremely powerful. And this was a particular tender package that I worked on as well. So you can actually see here on the left, this wall on the left-hand side is actually a stacked wall. So we've got a foundation footing, we've got our rising wall, and then from the insulation point up to the roof, that's one wall type as well. So there's essentially 3 different wall types in there, just created as a stacked wall. So if anyone tells you you can't do technical detailing in Revit, you definitely can. And we can even add 2D information over this, or even add our detail into the wall to roof junction as well if we want. Linking in CAD, you will find yourself linking into CAD quite a lot, and I'd recommend it. Definitely when starting off. So bringing in floor plans, for example, import in a CAD plan into Revit. And it comes in the same way as an XREF will come into AutoCAD. Import in a floor plan, whether it's a site plan of the boundary of a site, for example, import that in, and then you can actually trace over that using the Revit walls, for example, as well. And I'll show you that in my example. Tagging. So one of the, I suppose, once I got past the point of using Revit just to produce my 3D models and 2D drawings, the next item I then started to focus on was using tags, and you can use something called a multi-category tag, and you can smart tag elements. So this particular door has been tagged here for the number 129, so that's some sort of door type or door numbering, obviously, in the project. And if I was to place a tag on that same door in this project, the same number is going to come up in the 3D view, in the 2D view, in the elevation, and that uses something called multi-category tags, and I'll show you a quick example of that in the demonstration. View templates, very powerful within projects. These allow you to control your visual appearance of a model, of a 3D view, of a 2D view. Once you apply a template to a 3D view, you can apply it to another 3D view, and it will apply the same settings, whether that's the same color settings, the same objects will be turned off, the same shadow settings will apply. So it brings great consistency using view templates. And this is performed using the graphic display options inside Revit as well. So here we have a fairly basic looking, just gray, plain visual object or visual 3D view of a building. But on the right hand side, using graphic display options, the keyboard shortcut is GD for graphic display. You can turn on and off shadows, turn the sun intensity down, turn shadows up or down, and turn the ambient light up or down as well. And that's only view specific, so you can change it for a different 3D view if you're just trying to create a pretty 3D view. And you can turn it into something conceptual like this, even adding certain different colors to the roof, adding endpoints to make it look sketchy as well. Some people like it, some people don't. This is my particular flavor of just creating a conceptual design just to show it initially to a client. And this was done in a matter of minutes. I'd say about half an hour, all of this was created and placed onto a sheet. And not only was that created and placed onto a sheet, you've got your 2D floor plans, you've got all your elevations, any 3D view you want. Again, 1, 2, 3 floor plans, different types of elevations, even site plans and anything like that, and even shadow studies as well in about half an hour. So very quickly done. Color schemes is the next item I'm going to talk about, and color schemes allow you just to control the visual appearance of your drawings based on different types of properties. So color schemes can vary greatly, and they're quite far and wide in terms of you can apply it to different room types using room tags. So just be aware of applying color schemes. I don't have much time to spend on it today, but just it is very powerful for being able to just add color to your drawings that has a meaning to it. So such as all of these windows in this, or all of these rooms in the yellow category are related to a certain category of room. So maybe that's administration room in this building. All of the green rooms are then associated with maybe different types of uses. If it's teaching rooms or training rooms, you can categorize those as one, and they will all hold one color as well. So object-based filters. So object-based filters can be used for different types of elements, such as different types of walls, different types of walls with different fire rating. So maybe all of your 2-hour fire rated walls might be a blue color. All of your 1-hour fire rated walls might be a purple color, and you can completely control that by object-based filters as well, and based on fire rating, just to make you aware. So that's very powerful to automatically create your fire rated walls. And in CAD, I've seen this done where people then take, or before Revit, will take a CAD GA floor plan and they'll color all the walls themselves, whereas Revit is in fact doing it as long as you have applied the property to a particular wall in the properties tab as well. Phasing, very powerful inside Revit. You can apply an existing phase or a proposed phase to an object or to a wall. And the benefit of this is if you have existing structure that's being demolished, it will create your demolition drawings automatically very easily just by changing this setting or your view settings for phasing as well. So be aware of phasing and use it. It's very powerful. Room tags, very powerful. Capturing floor areas. So if I move this wall in this building, the floor area is going to automatically update. Therefore, you know how much carpet or how much floor finish you need for a particular room. Object properties, there are by default a lot of properties attached to objects. You can remove most of those properties, or you can add your own properties, such as fire rating, such as the name of the manufacturer, such as U values. You can also calculate U values inside Revit, by the way. You can add a cost to that particular property, such as a wall square meter rate, or a floor finish square meter rate. You know, a tile or a really nice tile might cost £100 or €100 per square meter, or you know, if you in fact change to the more expensive or lower cost floor finish, you can actually calculate that automatically in a Revit schedule. And that brings me on to Revit schedules. Very, very powerful. And I know I say this about all the features I'm showing purely because these are the features that I found most beneficial when I myself moved companies to move to BIM. And these are very easy wins for you to get used to as well. They don't take a terribly advanced knowledge of Revit whatsoever. So schedules allow you to quantify everything in your model, literally everything, every window, every wall, every window sill, everything that's modeled inside of Revit can be outputted to a spreadsheet. That is so powerful. And like we looked at the start, that is what becomes your database of your building. You can see it in a tabular form, and then you can just flick a view and you can see it in a 3D form as well. For example, if you look at all these different line items, these are all different windows that exist in this building. If I was to click on one of these line items, you can see it tells me what the height of that window is, the width of it, and the sill height, if it's whatever height it's at. I can right click on that and I can say highlight this in model, and it will bring you to that specific object in the 3D model. You don't need to go looking for it whatsoever. If I then delete that window, either in the schedule or either in the 3D model, it will no longer exist in the schedule or the 3D model as well. So an accurate quantification of everything in your model. Again, very, very powerful. And you can output these onto sheets. You can actually drag them onto sheets. And what I did on this project was I quantified the floor material takeoff, the wall material takeoff, so all of the plaster that was required, any of the rising walls that were required, roof material takeoff, even areas for demolition. I was able to quantify all of that, as well as in the middle column, you'll see I have window schedules, external door schedules, internal door schedules. So lots of information from schedules, place them onto sheets, and that can either be quantified for a tender stage. A quantity surveyor can use that information. You can even go to site as a designer and start marking off those items with the contractor. Has this been installed? What's the status of this particular item? All from inside your Revit model. So very, very powerful, I would say, once again. Right, so that's Revit. I'm just going to go into a bit more detail into BIM 360. So BIM 360, I will, just to be clear on it, BIM 360 it actually entails 4 different products. So BIM 360 Docs, BIM 360 Design, BIM 360 Coordinate, and BIM 360 Build. And the 4 of them do 4 distinctive different things. Now, BIM 360 Design, Coordinate, and Build all sit on top of BIM 360 Docs. So if you purchase any one of these, they're all separate purchases, you always get Docs as part of them. So Docs is probably the most basic level, and all of the rest of them are added on functionality, and I'll explain them now. So BIM 360 Docs, like I explained at the start, it allows you to store files, 2D, 3D, 50 different file formats, Word files, PDF files, in a cloud location that's accessible in a web browser. So that's it at a very basic level. So BIM 360 Docs, you can control different permission levels, like we've also seen, and view 3D models as well in the web browser. Now, BIM 360 Design allows you to collaborate with another designer on a 3D model that exists in the cloud, but by using Revit to actually collaborate with it. So you can link in a structural engineer's model using BIM 360 Design directly into your Revit environment, and you can both design at the same time and then sync your changes back to BIM 360, and then even view those changes in Revit a few minutes later from the structural engineer to the architect, and vice versa. It's extremely powerful, so just be aware of it. And you can do that from directly inside Revit as well, collaborating using the cloud. And then that model is saved in BIM 360 Docs once you're using BIM 360 Design. Some of this may be confusing, but I advise you to definitely look deeper into this. It's extremely efficient when working remotely as well, or when all of our teams are not in the same location. And you get what is known as the swim lane view. So swim lane view being this, you can see the purple line is the structural model or the structural team. The yellow line is the architectural team. And this shows you whenever they've synced their model to the cloud, and you know if you're working with the latest model or not as well. So that's it in a very simple form, but just to be aware of it. The next product is BIM 360 Coordinate. So BIM 360 Coordinate, again, sits on top of BIM 360 Docs. So it allows you to use whatever files you have in BIM 360 Docs. It then allows you to perform clash coordination in the cloud. So similar to what Navisworks does, but it does it in the cloud with your models that exist in the cloud in BIM 360. So it's just another module on top of BIM 360 Docs. As soon as you upload a model into a folder, so in this case it's a structural model, and you can see we've a shared folder on the left-hand side. What we've told model coordination to do is, as soon as a model gets uploaded into any of the shared folder, it will automatically run a clash detection. So you don't need to do anything. It will automatically clash each model against each other. So we can see here we've got two models. Structural model is the top line, the bottom line is the architectural model, and it's told us that there are in fact 8 clashes between those two models. So you might say, okay, we can see there's 8 models, we actually can't see anything. Well, in fact, you can go into that model and it will bring you to that particular clash in BIM 360 coordinate in your web browser. So what you can then do with this is assign that clash to the relevant person. So what we can do in this example is we can create an issue for all the columns and assign it to the structural engineer. So we assign it by just simply putting in a text note on the left hand side, and we can, from a drop down menu, choose the structural engineer or their company name. They will automatically get an email to tell them that something needs to be resolved in the model. So then what happens? In the text box, you can see here down the left hand side, I've tagged myself in this example. I've tagged myself, and then that person, whoever you tag, by using the @ sign, the same way you do on social media, use the @ sign, put their email address or name after it, and they'll receive a notification. And the notification will actually bring them into this particular view as well in their web browser, and they'll be able to resolve that clash. So what happens after that clash? The structural engineer then realizes that they have to move their columns inside or outside of the curtain walling. So the structural engineer then opens up their structural Revit model, moves the particular columns, and then they just synchronize that back to BIM 360. Very simple. The clash has been avoided. It means it hasn't happened on site. And I know this can happen for quite minor stuff where it happens on site and people are left without the right information to, set out their foundations or set out their columns or even set out their ductwork as well. This is all being resolved virtually with a lot of automation in there as well. So that's BIM 360 Coordinate. That's a whistle-stop tour. It does a lot more, but just to make you aware of it, that's what it is. And the final product I'm going to touch on is BIM 360 Build. So BIM 360 Build allows you, again, sits on top of BIM 360 Docs. It allows you to create RFIs, submittals, even take notes from meetings, even set up Zoom meetings from within BIM 360 as well. You can link your Zoom account to it. So just to be aware of that, very, very impressive stuff. So that's called project management as part of BIM 360 Build. There's also something called field management as part of BIM 360 Build. And this allows you to create checklists that you can in fact use on site, and then even create issues against those checklists. So a checklist could be a quality inspection checklist. Has this window been installed correctly? It can be a health and safety checklist. And then you can create issues and again, tag relevant people in the activity log, and they'll get a notification if they need to be notified. Okay, so for the next kind of 5-10 minutes, I'm just going to do a bit of a demonstration inside Revit to kind of reinforce what we've gone through, and then we'll have some time at the end for questions. So I am just going to share my screen. So perfect, my screen is shared. So I'm just going to show you some examples of projects that I have worked on here previously. And the reason I'm going to show you these, as I said, I just with the bandwidth in my current location, I'm not going to open the larger projects. But this example, this is the 178 housing estate that we actually worked on. And this is a 3D model or a BIM model of a house that we modeled. So just to show you some principles that we actually used in this, and we actually used this as a training project in the office that I worked in. There were lots of different house types, and what we did was we got each different person on a Friday afternoon. We ran a Revit training session, and we got them to model up a different house type. And then with the house types, we actually linked them into a complete site plan of the whole project of 178 houses. And I've got a small example of this in here. So what I'm going to show you, so this roof, if I select this roof, once I select this roof, I can go in and edit the type of this roof. So let's see what the buildup of this roof is we've got a slate finish. We've just given it 25 mil, wood timber lats on that 35 mil. and we've just shown a timber or joist rafter of 172 mil. So I could go in here and start to add dry lining, plasterboard finish, even a paint finish if I want, very easily. And that will appear in there, and it will reflect in my roof type in here as well. So just to make you aware of that. So that's the roof buildup. What I explained about modeling floor to floor. So here we have a wall. You can see once I hover over them, I've got our top floor wall and bottom floor wall. So ground floor wall. This has been modeled from floor to floor. You can see it sits on top of our rising wall here and just runs up to the top of our floor slab in our building there as well. So as you can see here, there are a couple of different windows. So each of these windows is an instance of a window. So all of these windows are in fact the same windows. I can right click on this window. I can go select all instances in entire project, and it highlights all of those windows in blue. I can then drop this down and say I want to change the size of those windows. Let's see if these fit in there. They might be too big. There we are, and you can see all of those windows have updated automatically. And then in our elevation views, oh, I've got some sheets placed down here. All of those windows have automatically changed in our window views there as well. So I can in fact select these windows just at the front and change them back to maybe the same window that they were at before. So that's updated in that particular view as well, updated in the elevation, in the 3D view, and then even on our floor plans as well. That's also going to update. So what I'm going to do is just select on this window, and I'm going to show you this particular window tag. So I have modeled that correctly. I'm just double checking. So when I select that window, on the left hand side here, it gives me what are the instance properties. So the instance properties are only for this single existence of this particular window. If I now go into edit type, any property that I change in here will reflect wherever that window repeats across the project. So if I was to change window T02 to, we'll change to 12. So it's window type 12. Hit apply on that. You can see every other window has updated to window type 12, just from the number from the instance or from the type parameters in there as well. If I now want to, what I'm going to do is create a 3D view. That's my default 3D view. So that is a CAD plan that we traced over. So what I'm actually going to do is, I'm going to create a 3D view, and it's going to go to a top view. I'm going to go to 3D view, and what I'm going to do is just show you how to change the graphic settings as well as tagging that particular window. So I can go into my visual settings in here. So I have my original CAD plan that's linked in there. So if I just go to manage links, I can actually turn that off. So I've got my CAD formats. The floor plan is, yeah, that's a particular floor plan is actually linked in. I can turn that off from in there, or in fact, what I like to do is just EH or element hide. So what I'm going to do is graphically improve this. So I'm going to go to my graphic display options on the left hand side. This brings up this dialog. I like to work with shaded views. I turn on smooth lines with anti-aliasing, and you can see it's just starting to change color. And then with the lighting, I like to turn down the shadows, turn up ambient, and maybe turn up the sun. Just hit apply on that, and you can see it gives you a slightly different feeling on that. And oh, I want shadows to be cast, and that will cast shadows. You can see it gives a depth to it there as well. And cast ambient shadows, it kind of gives a bit of a tint to each different wall level as well. So what I'm showing you here is just to have a bit of a play around with these I suppose graphical options in here as well. I can turn on the background. I like to turn on the ground as white, and then I turn on the horizon as white, and you get a nice gradient of blue just kind of fades into the background. So you might say, okay, well, we can still see the foundation there. We don't want to see the foundation, so I'm just going to pull that view up a bit. You can move this around as well. So what I have also done here is I've linked in different elements that I've created already. So what I'm going to do is close that for a minute. I'm going to close everything else, open up manage links. So I've got some links in here, what are known as, I've got site context. So I'm just going to reload them. So these are linked in separate models. So this could be created in a separate Revit file. Click OK on that. And that's in fact my site context that I had prepared earlier. So it's brought in all my footpaths and my trees, all my different types of objects like that. What else have I got in here? I've got some other links that I can bring in. So manage links. I've got gardens, so reload. So that's brought in my gardens, and that's just as a linked object. And then I think I had some site context, or what I had actually done was placed different blocks, and I'm going to show you that now in this 3D view. So I've jumped into a different 3D view. You can actually see, as I rotate around that, we can see all of these LinkedIn models. Oh, one of them is duplicated. Brought in all of my LinkedIn models, my garden model, any sort of neighboring walls as well. And the final one I'm going to turn on, I've actually duplicated this particular block of houses. I've created it as a separate link. All I've done is duplicate it around. And this is a very efficient way of working, that you create a block or a group of something and place it in a LinkedIn Revit file if it's a duplication of that particular house type. So there we have a small housing state created. Some of the roads just need to be tidied up. That is my fault. But we've got this same house type created as a group and then just duplicated all the way across the site as well. So that's just showing you some basic principles of when you start modeling a project and how to build it up as well. If I go back into my 3D view that I created, there we are. We can now see the surrounding site context in there. I can turn off this model if I don't think it's fitting in with what the visual I'm trying to create, and you can even add in more ground information into here as well. And you can turn on something called the realistic view, and it will just bring in the different items or different properties that you have attached to your particular item as well. So that brings in a realistic view and just applies a material that I will have applied in my wall build-up. So if I go into my wall build-up, go into my brick, and you can change all of these. You can create your own custom materials. So in here, appearance. So that's the brick detail that it's bringing in. I can in fact go into my library of information and or library of materials, and there are thousands and thousands of different types of material finishes in here as well, different types of brick, and you can create your own custom library as well. I won't go through them now, but even things like flooring as well in there too. So just to finish off then, what I will show you is, so I've just one other example of a project here as well that I worked on. And this was just a one-off house I worked on. So this was the existing site we modeled. And what I'm going to show you here is the phasing. So what I'm going to do is go show new construction. So the garage has been demolished and my new house is now in here as well. And what I can actually do is change I can change the visual appearance of that, so everything grays out except for the proposed elements of that as well. So everything in proposed is showing in color, and everything that's existing is showing in gray. So if I select this roof and go to my object phasing properties, that is set to existing. If I set that to new construction, for example, and come out of that, it will highlight in a different color. So you can see there, if I change this to new construction, it's going to highlight in, oh, sorry, that was changed to a different phase. Oh, phase demolished, that's why. New construction, change that as well. So you can do that with your buildings, and maybe part of this building was already existing. So let's say this wall was already existing. I can change that to phase created existing and just turn that onto that phase. And what I can also do is go to my demolition, and it will highlight what is actually being demolished, which is this particular shed, and you can see it highlights in red as well. I can change the colors of that too. And that automatically creates our demolition drawings as well that can also be placed on sheets. And for this project, I also created shadow studies. The planning authority wanted a shadow study on the neighboring house, and we were able to show it at different times of the day, simply by just changing our shadow settings in our graphic display options. So we were able to change our sun settings in here, and for the exact location of the building, the time of year, 21st of March at 10 a.m., we could show what shadow was being cast on that as well. Okay, I might wrap it up there to take a couple of questions. I see that there are a couple of questions in, and I'm happy to jump onto them now.
Yeah, great. Thank you so much, Jonathan. That was very informative. A lot of things to take in there. Fantastic display of what Revit can do and what BIM 360 and what AEC Collection can do to help everyone. So we'll dive straight into the questions. Everybody's in there. One other quick question. I think you might be able to answer quickly. When you were doing the view, adjusting the view to suit you, 3D view, can you turn the line work off in your graphics display?
Can you turn the line work off?
Yeah, when you're doing graphic change, adjusting the graphic display in your.
Oh, you can, yes.
Yeah.
And I will have a view here of this. Yeah, you entirely can. It's one of those graphic display settings.
Okay, perfect.
GD, type in GD, but you can. It's other we are show edges.
It's the edges, yeah.
Yep.
Okay. We jump into some of these in-depth questions here.
Yep.
So from Gareth, we'll go through this one first. When you change the window type from WT02 to WT12, there were technically two different window types. There was an opening vent that was in there in one of them and not in the other. Assuming therefore that the window schedule will be incorrect.
Very good point, and that's just from my modeling, and I'll actually show you how I will correct my own mistake. And that was probably my laziness. I would say, and very well noticed. So you're dead right. These are two different window types. So this particular one, let me see on the left hand side here. So there is a setting on this window to say if it's opening swing side left or opening swing side right. What I could actually do, and it depends how you number your windows, I could create a separate window schedule. So if I go into my window schedule, so what I'm actually going to do is go into my window schedule and see if I can add in that particular parameter. I'll try to do this on the fly now. Opening left. So door lock type, window lock type.
Jonathan, have you set it up as a shared parameter?
It's oh, I don't think it is.
No, it'll only come in there if it's a shared parameter.
So you can then, like Lee said, if you set it up as a shared parameter, you can in fact have that as window type 12, and you can have left-handed and right-handed in here. The other thing that you could do is you could duplicate this window. So duplicate whichever one is left-handed, go into edit type. What I'm actually going to do is I'm going to duplicate this, and I'm just going to call it, let's call it window type 13. So window type 13, and then I'm going to change that to 13. That's correct. So now if I go back into my, that's just going to update. Back into my front elevation, you can see we've got window type 13 and window type 12 now are separate there as well. And then I can just change this particular one to window type 13.
Yeah, so ideally you want to be doing,
that's another way. Yeah.
Ideally you want to be doing every single change. You want to be having it as a new type.
Yeah.
Right. Yeah.
Yeah, it depends on the project or how complex your I suppose your window types are.
That's exactly, yeah, exactly. How if it gets more complex, you want to record that, and it can be recorded like you showed. You can add more schedule parameters in there, sharing parameters, add more in there, and have it more.
Exactly. Yeah, I probably didn't go into enough detail in the scheduling, but yes, you can add almost any parameter you want.
Perfect. So, just going on from that. Do you think, so this is creating your own families and instance types. Do you think it's a time-consuming process? And Lee, you can weigh in on this one if you want as well, please. Is it a time-consuming process? I'm guessing at the start it is.
Yeah, so usually what we say, or what I say when I'm training somebody, say from Revit Essentials, is we don't tend to go into creating your own families at that point. So Revit, as Jonathan showed, Revit comes with quite a big library anyway. But what you do sort of find is that when you're working on a real project, you need a specific window to go into that opening, or a specific door type, and that's when it comes to making your own. And I just saw in the chat somebody did ask a question on where you can get download families from. Unfortunately for you guys that are just going in, starting your BIM and Revit journeys now, there are a huge amount of Revit libraries out there. So I mentioned a couple earlier, like BIM Object is available online, or the NBS National BIM Library. And you can download manufacturers specific windows from that. But again, what usually happens is it doesn't have the specific window that you want, or a specific element. So therefore you're into making your own. And what I like to say is you need to be using Revit for a little while before you start to make your own families or your own content in Revit, just because you need to know how Revit works for things like the difference between instance parameters and type parameters. These things we can teach you in the essentials, but you really need to just grab them as fundamentals in your brain so it's become second nature. But once you do that, I've got a simple course which takes you through in a day, which will teach you then how to create your own content. So we go through, and actually in that course, we start with a very simple profile. We then go through and look at just 3D modeling, how you 3D model as you would in, say, something like SketchUp or whatever. And then we move into actually making a parametric component, and we actually use a window or a door in that typically. So within a day, you can get up to that if you were to come on one of my courses. But yeah, you do need time using the software first of all. But I think that's just natural anyway. You want a bit of time using the program in its simple form before you get into the more advanced subjects.
Yeah, and that just leading on to that, another question. Most everybody here will probably be leading on from another form, or even AutoCAD 2D to Revit. What do you think the approximate time and potential learning curve issues are? If you can just summarize that for us as well. You can probably find.
Yeah, obviously depends on where they're coming from. So again, if we just take a typical, I'm going to stick with architects because that's what I mainly train. So a typical architect or interior designer or something like that, they're coming from AutoCAD or Vectorworks or maybe even MicroStation. We do a 3-day essentials course. So that 3-day essentials course gets you up and running and understanding how Revit works, and being able to, what I say is sort of get you up to a planning application level. In that we do cover detailing, so you would be able to do construction drawings or whatever, but that type of level. What I do say, and in all honesty out of that, is hopefully you come away from that course and just saying, wow, Revit is amazing, we can do anything we want to do in that. Wow, Lee Milligan is an amazing trainer, talking about my third person. And yeah, we're going to go and crack the world now. What does happen is you get to that point where you just need those specific families that, as we just talked about or whatever, but you almost need to go through that pain process first of all. Then you come away and say, oh, Revit doesn't do exactly what we want. Lee didn't show us how to do these, create these families. And then we come back and we just do that simple day's course along with a few other workshops that we can do. And that just brings you up again. So you do sort of go on this roller coaster ride with it, but 3 days will get you up and running, being able to create projects in it. Then about a month later on down the line, maybe you're at a point where you're ready to go and you can start to say, right, I need to look at this part isn't quite working for me in Revit, or this part isn't quite working for me in Revit. And then we just work around you in workshops. And that tends to be very specific on what type of jobs you're doing.
Perfect. So yeah, it is a very not a complex move, but it's depending on your situation, definitely depending on the situation and how much you use it afterwards. It can be very fast, or it can be slightly steeper. But I'll tell you a couple of questions we got around internal and external refurbishment works for existing buildings, primarily historic buildings. So Eddie asks, working on historic buildings, we're only given 2D information. Is Revit primarily built for new builds projects, or how do you use that information the best to work on these types of projects?
It's definitely built for working with existing structures and historical buildings, and the reason for that is, for example, in the AEC collection, there is a tool called Recap Pro, and if if you have a surveyor like I showed that captures laser point scans, you can actually bring that into Recap and analyze the information, or tidy it up in a 3D format and then bring it into Revit. And that's where I've definitely seen one of the biggest benefits of working with, in particular, historical buildings, is having a surveyor capture a laser scan, and being able to bring that into Revit is extremely easy, and something that you couldn't do as easily in maybe a 2D environment. Would be my response to that.
Yeah.
Yeah, and I'll second that as well, but just say that it is, just, speaking honestly, it is tougher to work on refurbished buildings or whatever, because we don't tend to have nice straight walls, and undulating floors or whatever. That does take longer if we are modeling it. That takes longer for us to model, and have to be more precise. But the benefits are that you are working once, you have to do that in AutoCAD as well, or if you're or in 2D CAD. So if you only have 2D surveys or whatever, you are missing information, which is when you get to sites and you see that a wall is actually leaning or whatever, and whatever you're putting in there doesn't quite fit. Within Revit, and as Jonathan said, if we get a point cloud survey, even better, we see all of that information and we can make more informed designs. I think that's the key part to it. It may take longer to model it in the first place, but we get it if we are going to be modeling it ourselves. But we get better information from that. It doesn't have to. We can do exactly like you did in AutoCAD, just trace over the top of those lines, but we're not getting the full information in it then. So the more time you put into modeling an existing building, the more accurate the information is going to be, and the better your design is then able to be because of it. I've worked personally with quite a few customers which do work on those type of listed buildings, and once they get their head around that process of actually it's going to be a much better workflow, and we're negating, or we're getting rid of the risk of problems on site, that's one of the biggest benefits to you working on a refurbished building like that. But it always comes down to the survey information you get as well. So what is behind that bulkhead or whatever, but that's still down, that you get those problems in 2D surveys as well.
Yeah,
exactly. And I think like either way, you're better off using Revit, even if you're only being fed 2D information. Like if you're only being given a 2D floor plan or 2D section to work from, you can still set up views inside Revit that only reflect those particular sections that you have, without making assumptions in between. And then even for your own workflows, is depending what you're modeling, you'll still get the benefit more so using Revit, even with those 2D information linked in.
Yeah, I mean, that definitely depends on it's better to start and do that work within Revit first, and then it becomes easier once you've got the existing modeling models for those listed buildings, historical buildings, etc. Well, Jeremy, Paul, I hope that answers your questions slightly on that. I hope that if you have any other, do let me know if you have any other thoughts on that you want us to answer. Before I go into some questions about MEP, just wanted to ask this quick question that we had raised by Mark. When you replace the wall type, is the new wall type changed about the center line of the wall or the front back edge of the existing wall? I think that's within the actual.
You actually have the option of changing. So in this particular view, so for example, I'm going to choose this wall. When you place a wall, by default it's usually set to, for example, it might be set to wall center line. If I now change that wall type, yes, it will change on the center line. Now what I'm going to do is just undo that. If I was, which is probably more realistic, if I change it to finish face exterior as the location line, it'll apply on that. And now if I go and change that to this particular wall, it will change along that particular line. So it's usually set at a default, and you'll figure that out as you go. But yes, you can change that setting, and I think it's a very good point, because obviously it's going to vary per project, and particularly if you're working within tight constraints on the site.
Yeah, perfect. So I've got a few questions on MEP, and before I go into that, I want to ask one other thing, just to differentiate Revit LT and Revit. So just one question that might be asked: doesn't Revit LT have the same material libraries as full-blown Revit? Do you know what particular changes there are within Revit LT and Revit that you got to be aware of when you're considering the two? So what?
Do you want me to take that?
Yeah.
Yeah. Okay. So the main difference is collaborative working. So in the full, what I call the full Revit, you can have multiple people working on the same file at the same time. And within Revit LT, it's made for just one person working on a file at one time. So it's really made for those smaller practices or those smaller jobs. That may not sound like a big deal, but if you imagine, if you're working, multiple people are working on a file in, say, 2D AutoCAD, you can have someone working on a plan, someone working on an elevation. Those they can be working in two separate files, because we can XREF them in, or we can just have them in as different files. In Revit, everything is in one file, so it means you can only have one person working on that project at a time, without having to split the model up and link it into, which is quite complicated. So you just don't really go down that route. So it's one person working on a file on their own. That's probably the biggest one. So working collaboratively, it's made for singular use. There are things like rendering within the product. It doesn't have that functionality. You can render in the cloud, but you pay within Autodesk Cloud units, you pay per render in that case. And there's a few other bits like massing. So doing feasibility studies, like Jonathan showed with Formit, you can do similar things inside of Revit with massing. Doesn't have that. And it is also missing in-place families, which is quite a big one, to be honest, as well. So if you wanted to, you can always create your own families, so loadable families like doors and windows. That can be done in Revit LT. But actually creating it within a project, you have to do very rarely. But when you need to, you need to. That's not in Revit LT. But yeah, the biggest one, if you ask me, would be that it's missing. There's a few other little ones as well, but the biggest one is that you are missing collaborative working, multiple people working on the same file at the same time. In Revit, if you wanted to go and find a bit more information about that, in Revit, for multiple people to work on the same file at the same time, that's called work sharing. So all working collaboratively.
Yeah, I think the in-place families one there are workarounds towards it, but you find that it's much better in the full-blown version.
Yeah. So and I just saw another little question which popped up there. So yeah, also it is missing the
structural MEP, isn't it?
The structural and MEP on there as well. So the specific tools for structure and MEP you don't get in in LT. Yeah,
you don't. You get basic structure, but it's very, very basic beams and columns and stuff.
Which maybe you can help on these MEP questions a little bit. If not, we can come back to you with some more detailed answers in an email. But just about Revit MEP, after importing a model, so just about, can you import MEP models after importing a model from the architect? So you can do that. You can work on it in Revit. You can
link in an architectural model. They're all an RVT file type. So you link them in with each other. It has just on the view tab, on the view properties, you can choose which discipline you're currently working in. So that will have different settings on how a model will show or not. So I think by default, and Jonathan, you can do it in there as well. Yes, but in the properties a bit further up, I was thinking, Jonathan. Sorry.
Oh, sorry for your view settings.
Yeah, so just a bit further up in the properties there. You have display, so you've got options for coordination, architect, structure, or electrical and MEP, and that will just show your discipline. There we go. So that will show your model in different ways depending on what discipline you're currently working in. So it would possibly half tone the architectural model if you were MEP. But yes, you can link them all in with each other.
And you can set that up as you see fit, the disciplines.
Yeah.
And there is a webinar that we've done previously last year that you can have a look at, which goes over the BIM 360 side of things, in terms of design and working with different models, architectural, structural, MEP, and how to put those two together, all three of the four of them, even more of them together. So that's very
Jonathan
useful.
Probably doesn't have time to go into it, but another question is, how do I apply MEP like ductwork and pipe? So you can see on Jonathan's ribbon at the top there is a systems tab, and that's where you have your ducts and your pipes and your, we do need to, because Revit is now, all the vertical products are in the one. So in the old days, it used to be Revit Architecture, Revit MEP, and Revit Structure. They're now all within one package. What we do you need to, Jonathan's probably in an architectural template at the moment, so it doesn't have a lot of the duct settings already preset. So for example, if we wanted to go and put connection joints on that or whatever, we would need to preload them in. But that is, yeah, so along that tab, basically you get all of those settings in there, and you can manage them. And again, it just means that you're moving from that 2D workflow to a 3D workflow. Just what Jonathan's hovering over across there, I've found MEP guys are really get excited about cable trays and so on. So being able to actually have those physically in a drawing and see the clashes, typically with structure, that happens in a model, is invaluable to the contractor and the client at the end of the day.
And for example, this could be a LinkedIn MEP model from another consultant, and the architect knows they need to create an OPE in this wall that needs to go onto a drawing for the contractor, for example.
Yeah, and then just one more of those questions on MEP. I just see it there. Revit MEP layouts from Revit back into AutoCAD. Yep, you can export from Revit be Revit MEP, Revit Structural, Revit Architecture. You can just export out as a DWG. So yeah, file export.
Yes.
And then you can take that out. By default, I think it takes it out. So you choose which layer standard you want it to go out to. So you can take that out as a British standard 1192, which is in there. So in the little dot beside where it says in session, in there. So
there's a BS.
Yeah, there we go. You choose your British standards. That's your layers that it's going out to with inside of AutoCAD. So once you've done that as well,
it is quite, I have to say that the export is quite powerful to AutoCAD. So there's good workflows there if you're going, if you need to go between the two.
Yeah, we do sort of recommend trying to keep it in the Revit. I think Jonathan touched on it earlier as well. So we do try and say, there is no need to go out to AutoCAD to detail or whatever. There are obviously times when other consultants are only using AutoCAD, so you need to export it to DWG. So there is the possibility in there. And yeah, you can obviously take them out to either your layers or the British standard is what we would recommend.
Perfect. So I think we'll probably wrap it up there. One last question with Lumion. Andrew asked, does Revit LT live sync with Lumion? I know Revit does. Revit LT.
I'm not an expert on that myself. I don't think it does, because you can't have any add-ins in the
you can't have
Revit
that's
LT.
Right. Yeah.
But we would need to Iqbal, you can just double check that and get back to them.
I'll get back to you, Andrew, on that. Send you an email to confirm that. Yeah, but it looks like I think we're at the end of the questions, and I think we'll call it a day there. If you have any other questions or thoughts, please do let us know. Email us support@cadpoint.co.uk. This is the last of the webinars we'll be doing for a while now, but please do keep a update on our websites, and we'll be sending out emails and some promotion just to help to let you know about any future events that we are doing. Thank you so much for joining us today. With thank you, Lee. Thank you, Jonathan, for your help and support today and your work today. Very informative. And stay safe, everyone. In these turbulent times, hopefully we'll be seeing more of this. We'll see you be able to see more of us, and we'll see more of you guys through this year. Help you guys. If you have any other areas which you'd like us to go into, or any other specific issues you want us to go into, again, email us, let us know your thoughts. There is also a feedback form that will come out to you guys after this webinar, if you just to gather up some of the ideas and thoughts that you've had from these two sessions. Click on when you receive the link when you exit the webinar, and in the follow-up email, if you could fill out, that would be very helpful for us to get an idea of how you felt and where we should all go from here. So without further ado, yep, thank you so much, guys. Jonathan, you've got to send me that house model. That was really good.
Yeah, no problem.
Keep
Yeah.
that there. And just to clarify, yeah, your courses are also very good, as well as Lee's. Nobody is more or less. You're both the same.
Yeah, exactly.
Yeah.
Exactly.
Maybe
Depends.
even better.
Yeah, it depends which accent you prefer.
It's true. It comes down to accent, the little details. All right, perfect. Well, stay safe, everyone. Have a good day, and bye-bye.
Brilliant. Thank you.